Welcome. Today we will see a very interesting equipment that forms a core part of any lab that deals with especially microfabricated microfluidic devices. You might have come across different types of devices that are made using microfabrication technology. Some of them are MEMS devices. What is MEMS? Micro electromechanical systems. They can be MEMS devices, MEMS sensors, or a different type of MEMS structure. Another class of equipment that is commonly fabricated using microfabrication technology are microfluidic devices. What are microfluidic devices? They will be small devices where you will have channels, small channels, very fine features like micron level features, and you will be pushing very small quantities, microliters of sample volumes through these channels and see the response. The flow rates in such equipment will be in microliters per minute, like 10 microliter per minute, 2 microliter per minute, 20 microliter per minute, and the flow rate is a point of very high significance, and you have to adjust your flow rate properly. Else for these devices, issues like leakage at the inlet outlet ports and leakage from the microfluidic device etc. may happen. How we fabricate these microfluidic devices is a subject of discussion at a later date, which if time permits, we will be covering that. Today what we will do is, given that we have a microfluidic chip, what is the equipment we use to flow at this very small rates and at high precision fluid flow rates. So that is what we will be seeing today. The equipment that is used for that is called a peristatic pump, which we will be seeing now. So this is a peristatic pump. So for microfluidic devices, you can flow the fluids, like it may be blood samples, it may be a solution that contains certain salts, or it may be a drug dissolved in a medium. So such liquids can be flown in a microfluidic device using either peristatic pump, which you see here, or syringe pump. So syringe pump is just like a syringe only, but its needles will be very small, and you will push that through the inlet and outlet ports of the sensor. Peristatic pump is much more advanced pump where you can actually circulate your liquid with high grade precision. We will see what are the features of this pump and how it is actually used to pump the liquids through a microfluidic device. So this is the peristaltic pump that we talked about. So as I told, there can be two types of pumps that can be used for microfluidic applications. One is peristatic pump and another one is syringe pump. A peristatic pump is technically a more advanced equipment. Now let us see, we have one microfluidic device which we have already tested in the lab. So I will just show it to you. Hope you can see it clearly. This microfluidic device. So here you see there are channels like this, and inlet and outlet ports are there. So the fluid in microliters per minute will be flown through these channels. This is what you call a microfluidic device. These are inlet ports, these are outlet ports, and this is where you load something like a static sample. You will load and keep here. So let us say we load cells or cancer tissue in this middle chamber. This is called a chamber. So we will load it in the chamber, and then what we will do, we will flow blood or drug or whatever you want to flow around your sample from here to here. You will flow it like this. So the liquid will flow like this or like this parallelly across both sides of the tissue, and then when it flows, it will diffuse because there are hexagonal barriers. You might not be able to see clearly because these are very small features. There are hexagonal barriers through which these fluids will diffuse into the sample and then cause changes which we can observe under a microscope. There are also microfluidic devices where under these chambers you have another layer where you keep sensors like impedance sensor, pressure sensor, chemical pH sensors, etc. This microfluidic device does not have it. It is just a one layer of acrylic sheet where we have engraved the microfluidic channels. So we will see how peristaltic pump can be used to test such a device, and you will understand and appreciate the equipment much more now. So, you see, this is the peristatic pump. The core part of the pump is the insert cassettes where you have the microfluidic tubes. So, this is a microfluidic tube. It has an outer diameter and an inner diameter. You will not be able to see the inner hole here, but here in this tube, the outer diameter is 1 mm, but the inner diameter, which is the actual path or the hollow region of the tube, is 0.12 mm. That is the diameter of the tube. So, fluid will flow through the 0.12 mm diameter tube inside, and the outer casing is just for physical strength and support of that inner tube. Now, this is a cassette. So, I will remove this cassette. I have removed one cassette. I have removed another cassette. So, here you see these structures, right? What are these structures for? So, as we have discussed, this equipment is not for pushing in high volumes of fluid, it is for pushing in microliters of fluid. So, how this equipment does that is, you see this cassette, right? These circular patterns will go and push like this. Push, I think I hope you are able to see this clearly. So, it will go and push every time this one, and then there will be fluid here, right? So, it will push the fluid like this it will push the fluid. At every rotation it will push the fluid like this, so that microliter precision of fluid flow can be obtained like this. See, I think it is clear to you. This is how this circular structure pushes fluid in this cassette. Now, let us see how these circular structures are moving. For that, we need to switch on the equipment first. So, I have switched on the equipment. This is the interface for the equipment. Let us go to the home screen. So, this is the home screen. So, we have set, so in this RPM measured is the actual RPM at which these motors are rotating, and 4 microliter per minute is the flow rate that we have kept for the channels. Then, so here, this is how we set the flow rate. See the cassette symbol here and that rotating structure here. You can see that, no? So, that's rotating circular pattern is the same, whatever circular patterns we showed you before, it is shown here. Here, if you zoom in, let us say you can see it here actually, it is difficult to zoom to this very small screen. So, here you can see actually the cassette. So, here this is the volume, what is the volume that you want to push in that defined amount of time. So, volume is given as 4 microliter and time is 60.5 seconds or 1 minute. So, what will be the flow rate roughly it will be 4 microliter per minute. Like that you can set your flow rate and accordingly the device will work. Let us see the next setting. So, you have to select what is the tube ID. What is ID? ID is inner diameter. What is the inner diameter of your tube? So, it is 0.13 mm. It is around 0.12 to 0.13 mm. You can set it according to the actual hardware that you are having on board. Then this is for calibration. These are general things. And then what is the language that you want to use. So, let us try to start it and see. Okay. So, now I have started the motors. So, see here, because we have removed the cassettes, you are able to see how these motors are running. See, one it is moving in one direction, in the other it is moving in the other direction. This also we can set here, which direction you want to push your fluid. As you push the fluid with the cassette inserted, it will actually push against the tube and then push the liquid inside. This is how this pump works. See, according to the amount of flow rate that you set, the speed of this flow will change. So, I have stopped it. So, when we stop it, it will actually show. So, let us say in the port 2, what is the exact amount of liquid it has pushed till now. Right now, we have not connected a cassette, but as per the rotation per minute and the values you have set, it will show that it has tried to push 2.06 microliter. Let's say I start again. So you see it is increasing. It is calculating that if the cassette was there, it would have pushed this much microliters. So if you have noted time exactly at end of 1 minute, because we have set 4 microliter per minute, exactly at the end of 1 minute or 60 seconds, it would have pushed 4 microliter. So it is getting updated. And see, because it has pushed 4 microliter, it stops and shows you what it has done. Now we have asked it to push only in the second channel. This 1, 2, 3, 4 are for 1, 2, 3, 4 separate channels. So you can flow 4 different liquids or flow it in 4 different inlet outlet pairs using this equipment. Now let's stop it and see how we can adjust the direction. See here, this arrow, right? This arrow shows in which direction the circle will rotate. So it is showing clockwise, so it will rotate clockwise. You can change it and then it will become anti-clockwise. So this is volume per time. How do you want to change it? Then do you want to measure in volume per time or something else, only volume or only time, or volume plus stop and push, stop and push, volume plus pause? What does it mean? I will push for some time, then stop, again push for some time. If you have a similar application, you can use that. Time plus pause, like push for 30 seconds, stop for 20 seconds, push for next 30 seconds, stop for 20 seconds. Those kind of things you can do. And you can even give a direct rate, like microliter per minute. And then volume, what is the volume that you want to push? Let's say suppose we increase this volume to 10 microliter accordingly, and then I will start the equipment. Then you will see that the motor that you saw will move faster. Let's just increase it now. So I am increasing it to 20 microliter per second in 60 seconds. So here you can adjust the direction. See, you are seeing the direction where you can see this white box that is there. It is showing the direction. Now it is clockwise direction. Let's say I change it. I click it, then I change it. See, it has become anti-clockwise. So this way you can change the direction in which it is rotating, like this. So once it is done, we do it and we come back. Okay. Now let's start and see if the speed has changed. See, now it is rotating at a faster speed. It is rotating at very high speed now compared to the previous one. For you to so that it is very clear to you, let me again go back and reduce it to a very small value. Then you will see this change in speed of the rotation of this motor. I am stopping it now. Now let's go in. So I am seeing the updated data of how much it has pushed. So the rate is 100 RPM. The RPM rotations per minute, it has become 100 RPM. And now, yeah, we have gone in. Let's change the volume to very small value, to let's say 0.5 microliter per minute in. So 0.5 microliter per minute, I have put that. So I am closing that now. See, now it is moving slowly. No, but it has not got updated. See here, it has not got updated. That is why it has gone back to its starting speed. Let's stop it. Calibration. So this is channel 1. So I want to make it for channel 4. So here this number shows which channel are you trying to change. So I want to make it for channel 4, channel 2, channel 3, channel 4. Okay. So let's remove this channel 2's cassette and see what is the rate now. So channel, let's make it channel 2, channel 1, channel 2, channel 2, channel 3, channel 4, channel 2, channel 2 has pushed 2.81 microliter till now after we restarted it. Now we have changed, as we had discussed, we have changed the channel 2's volume to 0.51 microliter per 60 seconds. For better clarity for you, all of you, I have removed all the cassettes and only shown the motors. So this is channel 1, this is channel 2, this is channel 3 and this is channel 4. So if you look at the settings, for channel 2 we have kept volume per time as a setting and the rate is 0.5 microliter per minute, basically 0.51 microliter per 60 seconds. This is channel 2. Please see my hand. When I start doing it, you should just focus on my hand, which is channel 2, and see how it is differing from the way other channels are rotating. Before that, let's see what is the rate set for other channels. So for third channel, only the RPM is set. Depending on the RPM, it will move. So third channel, it is 100 RPM. Fourth channel also, it is 100 RPM. First channel also, it is 100 RPM. But for second channel, we have set volume rate. So 0.5 microliter per minute. So what happens, this channel will rotate at a very slow speed compared to other three. Let's see what happens now. So now I have started it. See, all the other three channels are moving very fast and second channel is moving very slowly because its push rate is 0.5 microliter per minute. But you can see that it is still moving. This if you observe, it is slowly changing position. See, it has come till here, come till here, come till here. For better clarity, let's try to change the setting for one more channel. So I am stopping it now. Always stop and change your settings because this is actually dealing with many mechanical actuator components. So let's see, I change for third channel. I don't want rate, I want again volume per liter. So I will put volume per time. So then what is the volume? Let's give. Now this we gave in the second channel, we gave 0.5 microliter per minute, right? Now let's give 5 microliter per minute. 5 microliter for 6 minutes. 1 minute will be 60 seconds. So 0, 60 seconds. So I am saving it. Before we start, let's just check these channel settings of all the channels. So channel 3 is now what? 5 microliter per 60 seconds. Channel 4 is again 100 RPM. Channel 1 is 100 RPM. Channel 2 is 0.5 microliter per minute. And channel 3 is 5 microliter per minute. Now when I started, you will clearly be able to see how 100 RPM differs. First channel and fourth channel is 100 RPM. This is 0.5 microliter per minute. This is 5 microliter per minute. How each one differs, you will be very clearly able to see when I started. Now let me start it. See, these two are rotating at 100 RPM. This is rotating at 0.5 microliter per minute. This is rotating as 5 microliter per minute. So you can clearly see the difference in the way they are rotating. This is the core concept of a peristatic pump. Once we insert the cassette, it will push the tubes and accordingly circulate the fluid. Now how is that done? Let's have a discussion or demo on that also. So I think it is very clear to you now how this equipment works and how after setting the different rates, flow rate or RPM or volume, just the volume or time plus pause, you can do so many things like that. Let's also try one more thing. Let's change it to run and pause and run. Okay. So let's change the setting for this. Let's say channel 2. We are changing it to volume plus pause. So what does that mean? So my rate is 100 microliter. My volume, let's say we increase it to 4 microliter RPM with a 2-second pause. So there is a pause of 2 seconds. Let's say we keep the pause to 5 seconds, 3 seconds, so that you can see clearly what happens. And do this for, let's do this for 5 cycles, or let's say we do this for, let's keep it high so that we will be able to see it. Do this for 50 cycles. Okay, it is set, done. So now channel 3 is again 5 microliter per minute, channel 4 is 100 rpm, channel 1 is 100 rpm, but channel 2 is set for 100 rpm, 4 microliter with a 3-second pause for 50 cycles. Let's just start and see. So check channel 2, it is pausing, see, it will pause for 3 seconds and then it will again rotate. So let's say when it pauses, I will count 3 seconds, and you will know that it is working exactly. 1, 2, 3, it will start again. Stop. 1, 2, 3, it will again start. So we have set it like that, so it will rotate like that. See how interesting this equipment is. So this way we can actually do a lot of programming on how we want to flow things and have multifarious applications. Now let me stop this and let's see how this cassette. So let's insert the cassettes back. You have to be very, very delicate with this equipment. It's a very costly equipment. First insert this, then push this inside and hear the click sound that is inserted. Now how do we flow actually? So what we have to do is, first we have to, so this tube will hold certain fixed volume of sample content. So what we have to do is, first we have to connect it like this we will connect. Then what we will do is, the sample has to come from somewhere, right? So we will take a beaker. So we will have a dish with a beaker. Let's say we have the sample put in this Petri dish. You can see the Petri dish, right? So we will have the sample put in this Petri dish. We will keep the tube like this. Then we will start it. We will fix the time in such a way that this tube will start pushing out the liquid from the other end. So we will keep the liquid like this and then push it. So what we will do is, let's try pushing it with water. So I will fill water in this, and then we will see by the time it takes in and pushes out from the other end. So I have filled this Petri dish with distilled water. Now we have kept one tube here, the other end of the tube is here. Okay, it is clear to you, no? So we have set 100 rpm for this channel, right? Let's reduce the rpm so that you will be able to see it in real time. So we will go to channel 1 and rate we will change it to, let's say, 10 rpm. Okay, roughly 10 rpm. Done. So this is channel 1. Now what will happen? This tube is currently empty. There is nothing inside. We have put water on this Petri dish. Now it will take water from here, inlet, as the pump will rotate. It will start filling water here. Finally water will get filled through the entire tube and it will start coming out from this end. Once it starts coming out, we have to stop. Once we stop, what will happen? Both ends will have water filled, right? Fixed amount of volume will be filled with the both ends. Then these two, with the sample inserted, we can insert into our microfluidic chip and then keep flowing it. So this is how we load samples into the cassette of this peristaltic pump. So, let us see how it works. So, we now our objective of this experiment, we have to perform these short loop experiments, small experiments for us to understand how things work. So, we will start it and see when this water comes out from here. Because the diameter is very small, it will take some time. Let us just see. Okay, it is not happening because you know why? We have made a mistake. I will tell you what is the mistake it is, then you will understand it better. I am pausing it, I am removing the cassette and I will show you what is the mistake. So, we know that the source is here and the outlet is there, right? Now, I am removing the cassette. I am starting it again. So, what is happening? It is rotating this side. So, that means it is trying to take liquid from there and push it back here, which is not what we want. So, we need to change the direction of rotation to clockwise. Now, it is rotating anti-clockwise. Let us do that change first. So, I have changed it now. So, done, saved. Let us start it again and see if it is rotating in the other direction. See, now it has started rotating in the other direction. Now, let us see what happens. So, we will insert the cassette again. First this side, clip it, then push it, put it at the inlet port and then voila, you are ready to start. See, now actually if you see, you can see the liquid going up here. Finally, it will come out from here. Just have look at here. At one point, it will come out. Let me put it back to the petri dish itself. It will start dropping from there. Okay. Now, liquid has reached the tip. As we push more, the droplet will develop and finally the drop will drop. Okay, let us wait for the droplet to form, for it to become sufficiently heavy to drop, because gravity has also to play a role here. So, I hope you can see it. See, one drop has dropped. Let us wait for another drop to drop. Yes, you can see the droplet being formed clearly, and as soon as the droplet becomes heavy, it will fall. See, droplet has become big. Okay. Yes, the droplet is there, it has fallen down. So, this way you can actually, so now what happens? Now because 2 drops have already fallen, now you are sure that your tube is filled with water now. Now, these two we can insert in the microfluidic chip, and right now we don't have the connectors for it. So, we can insert it like this in the chip and then flow wherever you want. This is how you connect this is how you load samples into your cassette, how you will load it, how to make sure that it is fully loaded. From the other end, the droplet has to come out. Then once it is fully loaded, you connect it, set your flow rates, and then you are ready to flow your liquid for as long as you want. Hope you have understood the working of the peristaltic pump, what are the different features in it, how the pumps work, what are the different speed settings, directional settings, what are the different tubes. So, let us say I will show you another tube. So, this is this looks like a smaller tube, but then its inner diameter is much higher than this tube, but its outer diameter is bigger. This gives more protection, this does not give much protection. This inner diameter is 0.38 millimeter and outer diameter is 0.5 millimeter. So, this tube we purchased so that we can use it with this microfluidic device. So, you can insert it into this inlet like this. like this you can insert it, clear? We will insert it, then we will have a coupler mechanism that will connect these two tubes, and then again you can flow like this. So, you can, your device can actually have this microfluidic tube connected already, and then you can connect it to a peristaltic pump like this through a connector, and then again you can flow it wherever you want. So, you can ship your microfluidic device with the tubes also, that is another utility. So, like this tubes are available for multiple different diameters. Hope this gave you a good idea about microfluidics also, how to load sample, how to flow and everything, and hope it was a very informative session for you. It is a very fascinating field, microfluidics. So, if you are interested you can read further. So, microfluidic chips are also made using microfabrication technology, and they have to be flown at very high precision flow rates, as you have clearly seen, and you understood why a peristatic pump is very much required to flow at this very critical exact flow rates. Thank you. We will see again.